We're inside a cosmic hole, and nobody told us. Right now, you are standing on a planet that is spinning through space, not just spinning around the sun, but moving through our galaxy. And our galaxy is moving through space too. But here is what nobody told you when you learned about space in school. We are not moving through normal space. We are moving through something else, something almost empty. We are inside a bubble, a giant, invisible bubble in the universe. And this bubble is so big that you cannot imagine how big it really is. Scientists call it the KBC Void. Some people call it the local hole. And we are trapped inside it. You are inside a cosmic void right now, and you did not even know it. This is not a story. This is real. This is happening to you. And the scariest part is that scientists only figured this out a few years ago. For your entire life, everything you thought you knew about where you live in space was wrong. Let me explain what this means. When you look up at the night sky, you see stars everywhere. So many stars. It looks like space is full of stuff. But that is only because you are looking at our tiny corner of space. When scientists zoom out and look at the bigger picture, they see something totally different. They see that most of the universe is empty. Like, really empty. Imagine a huge room. Now imagine that someone sprayed foam all over the walls and corners. The foam makes weird shapes, like spider webs hanging in the corners. Most of the room is just empty air. That is what the universe looks like. The foam is made of galaxies, billions of them, all clumped together in long strings and walls. Scientists call these strings filaments. They call the walls, well, walls. And the empty spaces between them are called voids. Our galaxy, the Milky Way, lives in the foam. But here is the problem. We do not live in a normal part of the foam. We live in a spot that is cosmically anomalous, way more empty than it should be. This is the KBC Void, and it is absolutely massive. Here is how massive. The KBC Void is about 2 billion light-years across. 2 billion. That means if you could travel at the speed of light, which is the fastest thing in the entire universe, it would take you 2 billion years to cross from one side to the other. Your brain cannot really understand that number. Nobody's can. So let me try another way. Our galaxy is about 100,000 light-years across. The KBC Void is 20,000 times bigger than our entire galaxy. It is so big that it makes our galaxy look like a single grain of sand on a beach that goes on forever. And we are sitting somewhere near the middle of it. We are surrounded by emptiness in every direction. This void is not completely empty. There are some galaxies inside it. Our Milky Way is one of them. There are others nearby, like Andromeda. There is also a big group of galaxies called the Virgo cluster, but compared to what should be here, this place is a ghost town. Scientists looked at how many galaxies are inside this huge bubble. Then they compared that number to how many galaxies should be here based on the average for the whole universe. And they found something shocking. There are way fewer galaxies here than there should be. Some scientists say this area has 20% fewer galaxies than normal. Other scientists say it could be 50% fewer. Either way, we are missing a lot of galaxies. A lot of matter. This place is unnaturally, impossibly empty. Consider this for a second. You are living in a part of the universe that has half the stuff it is supposed to have. It is like living in a city where half the buildings just vanished. Where did they go? Why are we here? And why did nobody notice this until recently? The answer to that last question is simple. We did not have good enough telescopes. For most of human history, we could barely see past our own galaxy. We had no idea what the universe looked like at the really big scales. But in the past few decades, scientists built better tools. They built telescopes that could see farther. They built computers that could count millions of galaxies. And when they finally zoomed out and looked at the big picture, they saw the voids. they saw the cosmic web, and they saw that we are sitting in a very strange spot. The KBC Void was discovered in 2013 by 3 scientists named Ryan Keenan, Amy Barger, and Lennox Cowie. That is where the name comes from, KBC, their initials. They were studying how galaxies are spread out across space. They were counting galaxies in different areas. And they noticed something weird. In our area, there were not enough galaxies, way fewer than there should be. At first, they thought maybe it was a mistake. Maybe their data was wrong. But they checked again and again. The data was right. We really are in a void. Other scientists did not believe it at first. They thought maybe the void was just a small thing. Maybe it was not that big of a deal. But then more scientists started looking. They used different telescopes. They counted galaxies in different ways. And they all found the same thing. The void is real. It is huge. And we are inside it. Now here is where things get really interesting and really terrifying. This void might be breaking the rules of the universe. Scientists have a model for how the universe works. They call it the Lambda CDM model. It is also called the Standard Model of Cosmology. Basically, it is a set of math equations that describe how the universe was born, how it grew, and how it should look today. This model has been tested over and over again. It works really well. It can predict all kinds of things. It predicted the cosmic microwave background, which is the leftover light from the Big Bang. It predicted how galaxies would form. It predicted how fast the universe is expanding. This model is one of the most successful scientific theories ever created. But there is a problem. The KBC Void should not exist. According to the Lambda CDM model, voids this big should be extremely rare. Like, so rare that we should never see one, especially not in our own backyard. The math says that a void this large and this empty should basically never happen. The odds are incredibly tiny. But here we are, living in one. Some scientists did the calculations. They figured out how likely it is for a void like this to exist based on the standard model. And the answer was shocking. The KBC Void is so statistically improbable that it defies explanation. One scientist said the odds are so low that it is like flipping a coin 100 million times and getting heads every single time. It just does not happen. But it did happen. So either we got incredibly, impossibly lucky, or the standard model is wrong. Let that sink in. This is a huge problem for science, because if the standard model is wrong, then everything we think we know about the universe might be wrong too. This brings us to an even bigger mystery, one of the biggest unsolved problems in all of science. It is called the Hubble Tension, and we might be causing it. Here is what is happening. Scientists have a problem, a big one. They have 2 different ways to measure how fast the universe is expanding. The first way is to look at old light, really old light, light from when the universe was just a baby. This light is called the cosmic microwave background. Scientists can study this light and use math to figure out how fast the universe is expanding. When they do this, they get a number, about 67.5 kilometers per second per megaparsec. Do not worry about what those units mean. Just remember the number, 67.5. The second way is to look at stuff that is closer to us. Scientists look at exploding stars called supernovae. They also look at special stars that pulse called Cepheid variables. These stars help scientists measure distances in space. And from those distances, they can calculate how fast the universe is expanding. When they do this, they get a different number, about 73 kilometers per second per megaparsec. Hold on. 2 different methods, 2 different answers. That should not happen. Both methods are really good. Both have been checked and double-checked. Both should give the same answer, but they do not. This disagreement is the Hubble tension, and it has been driving scientists crazy for years. At first, scientists thought maybe it was just a mistake. Maybe one of the methods had an error, but they kept checking. They kept improving their tools. And the problem did not go away. In fact, it got worse. The more accurate their measurements became, the bigger the disagreement. One scientist recently said that the tension has now turned into a crisis. So what does this have to do with the KBC Void? Everything. Some scientists think the void might be causing the Hubble tension. Here is the key. When we measure the expansion of the universe using nearby stars and supernovae, we are measuring things inside the void, inside our local bubble of emptiness. But voids are weird places. Remember, they have less stuff in them, less matter, less galaxies, less gravity. And when there is less gravity pulling things together, those things can move faster. Picture this. Imagine you are in a crowded room full of people. Everyone is pushing and pulling on each other. It is hard to move quickly. Now imagine you are in an empty room. Nobody is pushing or pulling. You can move much faster. That is what is happening in the void. Galaxies inside the void can move away from each other faster because there is less gravity holding them back. So when we measure how fast the universe is expanding by looking at nearby galaxies, we are actually measuring how fast things are moving in the void. And things in the void move faster than they should. This makes us think the whole universe is expanding faster than it really is. But when we measure the expansion using the cosmic microwave background, we are measuring the whole universe, not just our local void. We are getting the real expansion rate, the average expansion rate, and that number is lower. So the two methods give different answers because we are living in a weird spot, a spot that is not average, a spot that is emptier and faster than it should be. This idea could solve the Hubble tension. It could explain why the two numbers do not match, and it would mean that our understanding of the universe is not completely broken. We just need to account for the fact that we live in a strange place. Remember, if this is true, our physics textbooks need to be rewritten. But here is the catch. For this explanation to work, the void has to be even more extreme than we thought. The void needs to be about 20% less dense than average, and we need to be really close to the center of it. When scientists first calculated this, they were shocked. A void that extreme should not exist, according to the Standard Model. Remember, the Standard Model says that the universe should be pretty smooth and uniform at large scales. Sure, there are clumps of galaxies here and there, and there are voids in between, but nothing should be this extreme. Nothing should be this big and this empty. Several scientists have now studied this problem. They built computer simulations of the universe. They used the Standard Model to create fake universes on their computers. Then they checked how often a void like the KBC Void appeared in those fake universes. The answer was almost never. Out of thousands of simulated universes, only a tiny handful had voids this big and this empty. And in those rare cases, the void was never in the same spot as the observers. It was always somewhere else, far away. But in our universe, we are sitting right in the middle of it. This is a massive coincidence, too massive to ignore. So scientists started asking uncomfortable questions. Is the Standard Model wrong? Do we need new physics? Is there something about gravity that we do not understand? Some scientists think the answer might involve changing our understanding of gravity itself at cosmic scales. When you tweak the equations of gravity in certain ways, big voids like the KBC Void become much more likely. They are not statistical impossibilities anymore. They are actually pretty normal. But most scientists are not ready to rewrite the laws of gravity just yet. It requires changing some of the most fundamental equations in physics, and it creates new problems even as it solves old ones. So the debate continues. The evidence keeps piling up. In 2025, scientists used new methods to study the void. By measuring ripples in space left over from the Big Bang, scientists can figure out how matter is spread out across the universe. And the measurements confirmed it. We really are in a void. In fact, the new data showed that it is 100 times more likely that we live in a void than in a normal region of space, 100 times. That is not a small difference. That is enormous. The scientists who did this study said their results showed we are almost certainly inside the KBC Void. And if that is true, then the void is probably causing the Hubble Tension. This is the biggest cosmological mystery of the decade, and you are standing right in the middle of it. But solving one mystery creates another mystery. If we really are in this void, then why? Why are we here? Is it just random chance? Did we just happen to form in this empty bubble? Or is there something special about voids? Maybe life can only form in voids. Maybe voids are the only places where galaxies can be stable enough and spread out enough for planets to form and life to evolve. Consider what the dense parts of the universe are like. In the filaments and walls, galaxies are packed close together. Stars are born and die quickly. Supernovae explode constantly. Black holes swallow everything nearby. It is chaos. But in a void, things are calmer. Galaxies are spread out. There is less radiation, less danger. Maybe voids are the safe zones of the universe. Maybe they are the only places where life has time to evolve without being wiped out. If that is true, then every intelligent civilization in the universe might be living in a void. Just like us. They would all think they are in normal space. But really, they are all in the rare parts, the anomalous parts, the empty parts. This is what makes the discovery so profound. We always assumed we live in an average part of the universe. We assumed that what we see around us is normal, but it turns out we might live in one of the rarest, strangest places in the entire cosmos. We are inside a 2 billion light-year bubble of emptiness, a place that defies probability, a place that breaks the rules. And we have been here the whole time, completely unaware. Now let me zoom out even more. Let me show you what the universe looks like at the very largest scales. Remember the cosmic web I mentioned earlier? The foam-like structure of filaments and voids? That structure fills the entire observable universe. The observable universe is the part of the universe we can see. It is a sphere around us, with us at the center. The edge of this sphere is as far as light has had time to travel since the Big Bang. That distance is about 46 billion light-years in every direction, so the whole observable universe is about 93 billion light-years across. Inside that enormous sphere, there are hundreds of billions of galaxies, maybe even trillions, and those galaxies are arranged in the cosmic web. Thick filaments of galaxies, huge walls of galaxy clusters, and enormous voids in between. The voids make up most of the volume. Scientists estimate that about 80% of the volume of the universe is voids. 80%. That means when you think about the universe, you should not picture it as a place full of stars and galaxies. You should picture it as a place full of emptiness, with tiny threads of matter stretched between the voids. Most of the universe is nothing, and we live in one of those nothings. And here is something that will really blow your mind. The voids are growing. Remember dark energy? Dark energy is the mysterious force that is making the universe expand faster and faster. Nobody knows what dark energy is. It is one of the biggest mysteries in science. But whatever it is pushing space itself apart. And this pushing happens everywhere. But in most places, gravity is stronger than dark energy. In galaxies, in galaxy clusters, even in the filaments of the cosmic web, there is enough matter and gravity to hold things together. Dark energy is pushing, but gravity is pulling harder. So those structures stay together. But in the voids, there is almost no matter, almost no gravity. So dark energy wins. It pushes the voids open wider and wider. The voids are expanding faster than the rest of the universe. They are growing like bubbles. And as they grow, they push the filaments and walls away. Over billions of years, the voids get bigger, and the filaments get thinner. Eventually, the filaments will break apart. The walls will dissolve, and the universe will become nothing but voids, just enormous empty bubbles with a few lonely galaxies scattered here and there. This will not happen for a very long time. We are talking tens of billions of years, maybe even hundreds of billions of years, but it will happen. The universe is slowly becoming more and more empty, and somehow that is beautiful, because right now, in this moment, we can still see the cosmic web. We can still study it. We are living in a special time, a time when the universe still has structure, when galaxies are still close enough to see each other. And that is exactly what scientists are doing. They are using the voids to learn about dark energy, because the voids are the only places where dark energy is really in control. By studying how fast the voids are growing, scientists can figure out how strong dark energy is. By studying the shape of the voids, they can learn about how dark energy works. The KBC Void is a perfect laboratory for this kind of science. It is huge. It is close. We are inside it. So we can study it in incredible detail, and the more we study it, the more we learn. But every answer creates new questions. New telescopes are being built right now. Huge telescopes with mirrors the size of houses. Space telescopes that can see farther than anything before. These new tools will let us map the voids in incredible detail. We will be able to count every tiny dwarf galaxy inside the voids. We will be able to measure exactly how empty they really are. And we will finally be able to test whether the KBC Void is really causing the Hubble tension. Within the next few years, we will have answers. We will know for sure if we are living in a cosmic void. We will know if that void is rewriting the rules of physics. And we will know what that means for our understanding of the universe. Imagine being the scientist who solves this. Imagine being the person who finally explains why we live in this impossible place. Imagine rewriting cosmology. That is happening right now, in observatories around the world, in computer simulations, in the minds of physicists who refuse to accept that the universe does not make sense. But even if we solve those mysteries, bigger questions will remain. What does it mean that we live in a void? What does it mean that we are rare? Here's what we know for sure. You are inside a cosmic void right now, a bubble of emptiness 2 billion light years across. You are surrounded by space that has only half the galaxies it should have. You are living in a place that is so statistically improbable it should not exist, but it does exist. You are here. And you have been here your whole life. You just did not know it. Now you do. Now you know that when you look up at the night sky, you are not looking at normal space, you are looking out from inside a bubble. And beyond that bubble, far away in every direction, the real universe waits. The crowded, chaotic, dense universe. The universe where things are average. But you will never see that universe with your own eyes. You are too far inside the void. The only way to see the real universe is with telescopes, with math, with science, and even then we can only see snapshots, tiny pieces of the puzzle. The full picture is too big, too far away. We are trapped, not trapped like in a prison. We can move around. We can explore our galaxy. Maybe someday we will travel to other galaxies nearby, but we are trapped in the sense that we cannot escape the void. It is too big. Even if we could travel at the speed of light, which we cannot, it would take 1 billion years to reach the edge. 1 billion years? That is longer than life has existed on Earth. That is longer than the sun will continue burning. By the time we could escape the void, our sun would be dead. Our planet would be frozen and dark. Humanity would be long gone. So this is our home, this void, this bubble, this impossibly empty corner of the universe. And maybe that is okay. Maybe that is even beautiful in a way, because it means we are special. Not special in the sense that the universe was made for us, but special in the sense that we are rare. We are living in one of the strangest places in the cosmos, a place that defies the rules, a place that should not be here. But here we are anyway, and we are figuring it out. We are asking questions. We are building telescopes. We are doing the math. We are slowly, piece by piece, understanding the void, understanding our place in it, understanding what it means. This is science. This is exploration. This is what makes us human, looking up at the sky and refusing to accept that things just are. We want to know how they got that way. We want to know what they mean. We want to know if we are alone. And we want to know if the universe makes sense. Maybe it does. Maybe it does not. Maybe the universe is too strange for us to ever fully understand. But that does not mean we stop trying. So the next time you look up at the night sky, remember this. You are inside a cosmic void, a bubble of emptiness 2 billion light years across. You are living in a place that should not exist. You are surrounded by mystery, and that mystery is calling to you. It is asking you to wonder, to question, to explore. Because even though we are trapped in this void, our curiosity is not trapped. Our imagination is not trapped. Our desire to understand is infinite. And that might be the most important thing of all. We live in a void, but we do not have to be empty. We can fill ourselves with knowledge, with questions, with awe. We can look at the vast emptiness around us and see not a prison, but a canvas, a playground, a laboratory. The universe gave us a strange home, an unprecedented home, a home that breaks the rules. And in return, we will figure out why. We will solve the mystery of the void. We will understand the Hubble tension. We will map the cosmic web. We will measure dark energy. We will build new theories of gravity. We will rewrite the textbooks. And one day, maybe centuries from now, maybe longer, some future human or alien will look back at us and smile. They will say, "Those ancient people lived in a cosmic void and did not even know it for most of their history, but when they finally figured it out, they did not panic. They did not give up. They got to work." So yes, we live in a cosmic void, a 2 billion light-year bubble that defies probability. But here's the thing. We found out. We measured it. We mapped it. We are solving it. The universe put us in the strangest place possible. And we are using that strangeness to unlock its deepest secrets. You are standing in a cosmic hole right now, and that hole might just be the key to understanding everything. Welcome home.